Okay, good afternoon. Right. So today we move on to our second topic. Remember, I told you. Okay, just give me 1 minute. Can you see the screen? Yes, you can, right?
Yes, sir.
Yeah. Okay, thank you. Right. Uh, right. So today we start. Remember, now we are halfway in the concept of ICT. Not halfway, actually, we have done only about 1/3 of the concept of ICT. But before continuing the concept of ICT, today we want to start the introduction to computer part as well. Okay, we just do a gentle introduction uh, into the introduction to computer, and if we have time, we'll do the history of computing as well. So the idea is we want to go through these two topics parallelly. Okay, so that is the idea. Do those two topics in a parallel manner. Okay, right. So note for today's session is available uh, under introduction to computer. So the topic number 1 is introduction to computer, and the quiz is available, and also the evolution of computer or the history of computer. So that is also available. Okay. So basically what we cover is, now we have covered the yellow parts that we already covered. Like last time we covered up to this point. Of course, we have to cover few more topics, right? Few more topics. We'll do that later. So today we start introduction to computer and also history of computing. And anyway, we'll highlight at the end of the session. Okay, at the end of the session, right? So let's move on. So I will be using the PowerPoint presentation. You have the PDF. Okay, you have the PDF. So in this topic, we discuss what is computer and how the computer operates. Uh, that is our topic, because next topic, third topic, is how the data is represented in the computer. The fourth topic is how the data is processed, or the Boolean logic. So therefore, we need to have a very good introduction to understand the third and fourth topic, because that is data representation in the computer and the fundamentals of digital circuits. So in order to do that, we need the very good understanding about introduction to computer. Okay, right. So let's move on. As usual, I will be doing it quite fast. That is the idea about this class is, okay. But at the same time, if you have any questions, you can ask at any time. You don't have to raise hands or whatever. Okay, right. So introduction to computer. So last time we discussed about what is data, what is information. Okay, uh, what are the features of good information, and so on. And the device that convert data into information is computer. Okay, is the computer. So therefore, let's look at what is a computer is. Okay, so first of all, you must have a really good answer to the question of what is a computer, or what is the computer, right? So you may be having different answers. Of course, you must have some sort of answer. That is why you are doing ICT. Okay, so basically the simplest definition is computer is a data processing device, right? As simple as that. A computer is a data processing device. So why do you buy a computer? It can be a laptop, it can be a smartphone, it can be a desktop, because you want to process the data, right? Process data. So why do we buy a washing machine? Because we want to clean dirty clothes. Why do we buy a blender? Because we want to blend ingredients, right? So why do you buy a vehicle or car? Because we want to do some transportation. So similarly, why do we buy a computer? Because computer can process data, or computer can process data into information. So therefore, the simplest answer is computer is a data processing device. Okay. So now let's look at what are the features of computer. Right? What are the features of computer? If someone asks, what are the features of a vehicle or car? So you must have answers, right? What are the features of a car? Car is a car is used for transportation. Car is a mechanical device. So these days we have electrical cars also, right? So most of the cars use hydrocarbons for power and so on. Now, similarly, what are the features of a computer? Of course, computer is a data processing device. Okay. So let's look at some of those features. So the most important of those features. Okay. So number one is, this is the most important feature. While most other devices or machines process physical things like your blender, washing machine, and so on, the computer process a conceptual thing, right? Computer process conceptual thing. So it does not process a physical thing. That is why computer is little bit mysterious. That is why computer is interesting, right? So computer process and conceptual thing, not a physical thing. So that is our number one uh, feature of computer. Second one is computer is a general purpose device. So there are plenty of devices which does one task. Right? Washing machine is not used for anything other than washing clothes. Blender is not used for anything other than blending. But computer is used for hundreds of things. So we can use computers for word processing, communication like WhatsApp, right? Arithmetic processing, okay? And robotics is there. And we can use it for artificial intelligence, AI related things. So it's there, we can't say just one use. So therefore, computer is a general purpose device. It doesn't mean that we can do everything in the world using computer, but definitely computer is not for just one task. So when you buy a computer, you do word processing, chatting, surfing the internet, right? And if it is in a business organization, the accounting systems and so on are in the computer. It's a general purpose device. Okay. Computer is a general purpose device. And another feature is computers comes in different sizes and shapes. Sometimes they are often very different. So we can look at a car and see that every car is sort of the same. So they have the wheels and so on. But if you take a computer, some computers comes as a desktop, some computers comes as smartphones, okay, and some computers comes as robotics, right, smart devices, and so on. So, but those are all computers. So the architecture and the philosophy is the same, but they can do different things. Right? So that is another reason why computer is a complicated, complex device. Because when we say computer, it comes in different sizes and shapes, and for different purposes. So now we are just presenting features of computer. Right. So let's look at what are the types of data the computer can process. Right? What are the types of data the computer can process? So remember, computer is multi-purpose device. It is not just for one thing. So therefore, there are plenty of different type of data the computer can process. And that is why our third topic is representing data in the computer. So what are the type of data? Obviously, computer can represent and process numeric data. Right? We can use computer for arithmetic operations like calculator. But calculator can do only numeric data processing. That is the difference between calculator and computer. Whereas computer can do numeric data processing, but addition to some other processing. Of course, the computer can represent and process characters and text. That is why we have word processors. Right? Even this is a PowerPoint presentation. So we use text here, text processing. The computer can process images, graphics. That is why we have Photoshop and so on. Paint. Computer can process audio or sound. So that is why you can hear my voice. That is why you can play music. Okay. So you have the audio players in the computer. The computer can store and process video. And computer can store and process logic values, Boolean logic values. And there are some more data which can be processed and stored in computer, like the data coming from sensors and so on. Okay. So we will look at in details how these things are represented in the computer in our third topic. So therefore, just be patient. But remember, computer can keep, store and process different type of data. Right? Images, audio, video, character, text, and so on. So that is another feature of computer. And of course, computer is a complex device. So remember, when we talk about complex things, sometimes we say it is not rocket science. So usually one of the most complicated device man has ever made is a rocket. So the second device is a computer. Of course, we usually don't say it is not computer science, but computer science is also as sophisticated, complicated as rocket science, because computer is one of the most complicated device the man has ever made. Okay. So there are reasons. One is computer process conceptual things. So processing conceptual things is always more challenging. Like more challenging than designing a blender, designing a washing machine, designing a fan, because we process data conceptually. And of course, when your device is general purpose, it's always going to be complex because it can be used for different purposes. So then it's not going to be a simple device. Even rocket is used for one purpose, just sending people and things to the space and taking it back. But computer, so many usages. Okay. And therefore, because it's a so complicated device, so usually one manufacturer or business organization is not capable of building the complete computer. Now, when you buy a car, maybe it's a Toyota car or Nissan car. Almost everything, if it is a Toyota car, almost everything is built by Toyota, or maybe at least 90%. But when it comes to computer, it is too complex for one company to build. Maybe you are buying a branded computer like Dell or HP, but maybe processor is Intel. Your memory chip is another company. Display is maybe Samsung. So that is how computer is made. Of course, we have brands, but even if you take Apple computer, so processor is now earlier Motorola, now Intel. So how do we manage a complex device? Right. So we collaboratively build it. Different manufacturers manufacture different parts and assemble it. So they are experts in their respective area. Intel is expert in processor. Samsung is maybe display technology, and some other companies in RAM technology, and so on. So that is how we tackle it. It's a collaborative effort, not just effort of one company for one computer. Okay. And therefore, we call it component-based architecture. Component-based architecture means we develop the computer as set of components fixed together. That is how we build a computer. Right? Set of components fixed together. So processor from Intel, motherboard from Gigabyte, display panel from Samsung, and so on. Okay. And the motherboard is capable of holding these things together. So then we say, yes, we have the computer. So this is called what? Component-based architecture. So we have standard components which interoperate. So what is the advantage of this kind of a component-based architecture rather than you build it as a one big monster device? For example, Rocket T is not a component. Rocket T is a one big monster. So it's easy to manufacture because every manufacturer concentrate on their part. Right? Their part. And easy to troubleshoot also. When you have issue with your computer, it's very easy to say, okay, your issue is with hard disk, your issue is with your RAM. Easy to troubleshoot. So that is why when you have issues with a computer, usually if you take it to a hardware shop, they will troubleshoot and even fix it within few minutes. And also easy to replace. So if something, say if hard disk is corrupt, it take only few minutes to replace it. It's not like a vehicle where you keep it in the garage for weeks. And it's easy to upgrade. So if you feel like RAM is not enough, say you have 4 GB, so you can upgrade it to 8 GB. If you feel like your hard disk is not enough, so you can upgrade it, or you can even take it to a SSD. So those are all good features because it's used component-based architecture. Easy to manufacture, easy to upgrade, easy to troubleshoot, right? Easy to replace. Okay. Because we are not locked into a one vendor. Okay. So this is possible because we use open standards. Open standard means, so those are agreed standards. Every manufacturer has to develop it according to that standard. So that is why one part can be replaced by another part. So you are not locked into one manufacturer when it comes to computer, which is good. If you have a vehicle, car in your house, home, so if it is a Nissan vehicle, you are looking for Nissan parts. If it is a Suzuki vehicle, you are looking for Suzuki parts. But if it is a computer, you are not looking for that part, this manufacturer or that manufacturer. You are just looking for RAM. You are just looking for a hard disk, which is good. So that is possible because the computer uses open standards. Okay. Right. So now we move on to the most important diagram in this topic. The layered architecture of computer system. So another feature of computer is computer use layered architecture. So we will look at few more layered architectures later on. When we look at databases, we will talk about 3-tier architecture of database. When we look at networking, you will look at 8-layer OSI architecture. So these layered architectures means the architecture is consist of set of layers. On top of the lower layer, we have upper layer, another layer. So this is the first layered architecture we look at. We call it the layered architecture of the computer system. So we can understand the computer as 4 layers, or if you include the users, 5 layers. Hardware layer. On top of hardware layer, you have the firmware layer. On top of firmware layer, we have the software layer. Of course, this software layer we can subdivide into 2 sublayers: the system software sublayer and application software sublayer. So then we have the users, because we are always using where, right? Hardware, firmware, software. So sometimes we call the users also as liveware. Okay. So what are the layers in a computer or computer system? Hardware, then firmware, software. Software is system software and application software. Okay. So this is super easy stuff, right? We are doing, right? So therefore I'm going a little bit faster. That is the idea. Right. So what is hardware? So hardware means, now you have seen the hardware shops, right? Hardware means basically, right? So in common, in general, hardware means bricks, steel, right? So those are the physical, tangible things. So in computer, when we say hardware, we don't mean bricks and sheets and so on. Hardware means the physical, tangible things, the hard things. Maybe your keyboard. Even the hard disk has hardware parts. Your motherboard, your display. So that is your hardware. So hardware part is your physical electronic parts. Sometimes physical electronic, sometimes just a physical. Like a mouse, mostly it is just materials. Keyboard, mostly materials, but there are electronic parts behind. But if you take something like microprocessor, it's again materials, right? Gold and things, but it has a lot of electronic parts. So this hardware is basically doing everything: input, output, storage, processing, communication. So all those things, we need the help of hardware. So we'll come back to the firmware later. So then we have the software. On top of hardware, of course, in between you have the firmware, we have the software. So software is doing all the programming, processing. So then you may be confused, right? Hardware also doing the processing. Software also doing the processing. So software is doing the processing at high level. Hardware is doing the processing at low level. Okay. So we can subdivide software into 2: system software and application software. So system software is predominantly your operating system: Windows, Android, iOS, Linux. So remember, we have a separate topic called operating system. That is our 4th topic. So there we will in detail look at what is operating systems. What are their tasks? But remember, operating system is the main software under system software. And of course, there are some other system software utilities like disk defragmenters, file compression software like WinZip, antivirus software. So those are all system software other than the operating system. And then you have the application software, set of application software. So basically, why do we buy a computer or any computing device like smartphone? Because we want to run application software. The operating systems and other things, just because we need it to survive. But why are we really interested in a computing device? Because we want to use application software. Maybe office packages, Word, Excel, graphic packages like Photoshop, communication application software like WhatsApp. And if it is business, your inventory management system, order processing system, accounting system. So those are all what? Application software. So basically the main reason for us to buy a computer is to run application software. Other things are just we need it. Okay. And in between the hardware and the software, specifically the system software, we have the firmware. So remember, hardware means hard, physical things. Software means just soft programs. So firmware is technically a software. Technically, firmware is also software. So then someone will ask, why do we call it firmware? So firm is little bit closer to hard, right? So we have the hard, soft. So in between we have firm. So hard is something like stone, soft is something like marshmallows. Maybe firm is something like how do you call it? Maybe a fruit or something. It's not as hard as stone, not as soft as marshmallow, but it's firm. Okay. So why we call it firmware? Technically, I told you firmware is also software, but the software is pretty much drive in the hardware. So they are more closer to the hardware. So they are bound to the hardware. So basically, the firmware run your hardware, or firmware facilitate your hardware to run, operate. So that is why we call it firmware. But remember, firmware is technically, it's pretty much a software. Or we can just call them drivers. Okay. Right. So now you must have very good understanding about the layered architecture of the computer. Right. Hardware, firmware, software, we can subdivide it into system software and application software. Of course, system software, we can subdivide it into OS and other utilities. And then, of course, the users, we can call them the liveware. So anyone who is using the computer, maybe for personal things or official things. So therefore, now remember, what is the purpose of computer? We want to convert our data into information. Right? So data is gathered through your application software, and information is given back or given to your output devices by your application software. So that is why we say initially your data is processed by application software. But when we say data is processed by application software, that data has to go to the ultimately the hardware layer, and at hardware layer it get processed by the microprocessor. Microprocessor is a hardware CPU. So therefore, yes, the logic is written in application logic, processing logic, but that ultimately transferred from system software to firmware to hardware. And the real processing happens at hardware level. Then that data has to come back as the information, hardware to firmware, system software, the application software, and application software gives you the output. So therefore, it's a journey that goes like this and comes back like this. It's super important that you understand what is happening here. Okay, so that is one of the objective of this particular topic, introduction to computer and computer architecture. Right. Any questions up to this point? So now you must have very good understanding about some features of computer. It's a general purpose device. We use layered architecture. It's of course a complicated device. It's a multi-purpose device and so on. Right. So the next feature is a computer is a digital electronic device. So we just try to understand computer. Okay. So there are different type of devices you may be using. Some devices are just manual devices. Right? Manual. So manually we do things. ගෙදර තියෙනවා නම් මෝල් ගහයි වංගෙඩියයි manual. කොස්ස ඉදල, right? Broom, knife, manual devices. So then we have mechanical devices. Yantrika. Mechanical. Okay. A bicycle. Mechanical. So then that mechanical device can be powered to make it as a motor bicycle, car. So then we have electrical devices. Electric bulb, electric oven. Right? So look at those things seriously now. You are in the advanced level. Right? Manual things are there. Mechanical things are there. Machines. Maybe powered also by electricity or something like hydrocarbons. So then we have electrical devices, electric iron, electric bulb, electric oven. And another type of devices we are using is electronic devices. So therefore, first of all, you must know the difference between electrical device and electronic device. A lot of students have no idea about this. So they have no idea. And they learn ICT without knowing the difference between electrical device and electronic device. Okay. So can someone tell me, according to your understanding, because you have done electronic in your O-level science also. So I'm asking the simplest possible question I can ask about electronic. There's no simpler question than this. This is the question you must have the answer in the very first day where you heard the word electronic or your teacher taught you about electronics. Right? So what is the difference between electrical device and electronic device? Anyone? Or what is the difference between electrical and electronic? So we have electrical technicians, electronic technicians, electrical engineers, electronic engineers, electrical devices, electronic devices. So my question is, what is the difference between electrical and electronic? Anyone? Okay, using electricity is electrical. So do you think that electronic devices doesn't use electricity? So then what is electronic? So that part is correct. But it's not 100% correct because you have only explained the first part. Electronic is working with electricity. Working with electricity. Using electricity, working with electricity. What is mean by using electricity and working with electricity? Can you explain it a little bit?
Difference between electronic and electric.
Can you repeat it? I can't hear you correct properly. Can you speak a little louder? Right. So what is the
Yes,
difference? Yes.
Right, so I'll explain you.
Yes. Yeah, now I can hear.
Electrical devices use electricity in
Okay.
order to process, and electronic devices are flows of electrons and
Hmm. So there's a key difference. So look at those two type of devices: electric fan, electric oven, electric kettle, electric bulb, electronic radio, electronic TV, electronic computer. So what is the main difference? Yes, both has something to do with electricity. That is why the elect part is there. Elect, right? Electrical, electronic. So in electrical devices, we use electricity just for power. That's it. So electricity is used to power it. Electric bulb. So it convert electric power into light. Electric kettle or electric iron convert that electricity into heat. It's just convert electricity into some sort of a other energy. Right? Electric fan convert electric energy into mechanical power, which rotate the right. So it's a conversion of energy. Electrical devices convert electrical energy into some other form, mechanical, thermal, or light. But when it comes to electronic devices, what it does? So electronic devices either generate signals. Now we have the word signals here. In electricity, we don't care about signals. Of course, the AC electricity is a signal, but we don't play with signals. But electronic devices either generate signals or process signals. Right? Process signals. That is not the purpose of electrical device. Your light is not processing signals. Electric car kettle is not processing signals or generating signals. But electronic devices either generate signals or process signals. Okay, that is a difference. So electronic radio, right? So what you are getting is audio wave. It can process that signal and convert it to audio wave. Same for television, right? So from the antennas and so on, what you get is signals. And if it is a smartphone or something, it either consumes signals or it generates signals. Okay. Computer also can generate signals for networking and so on. So that is the main difference between electrical device and electronic device. Okay. So electrical device use electricity just for power and it converted to another sort of energy. Whereas electronic device either generate or process or transmit signals. Right? Signals or waves. So computer is not an electrical device. Computer is an electronic device. Okay. Now, when it comes to electronic devices, there are two types of electronic devices. So those who are doing technology, I don't know whether you have already discussed these things. So what are the two types of electronic devices? Analog electronic devices, digital electronic devices. Analog electronic devices, digital electronic devices. So computer is a digital electronic device. Whereas your telephone, not a smartphone, telephone, TV, the normal television, normal radio, those are analog electronic devices. So now first we subdivided electrical and electronic, then electronic devices, which either generate, process or transmit signals, we subdivided into analog electronic and digital electronic. Now, what is the difference? Analog electronics devices process or generate or transmit continuous signals like this. Continuous signals. They don't all of a sudden change the state or energy. But when it comes to digital electronic devices, it generate, process, or transmit discrete signals. So we call them digital signals. So discrete means all of a sudden the energy level change. Not continuously like this. No, all of a sudden energy goes from this level to that level. So then we call it digital electronic. If that device is generating this kind of a signal, process this kind of signal, or transmit this kind of a signal, it's a digital electronic device. So continuous signal, discrete signal. Okay. So computer is a digital electronic device. So computer internally generate, transmit, and use, process digital signals or discrete signals. So that is why the computer is different from radio, television. Okay. But when it comes to digital electronics devices, it doesn't mean that 100% they are operating on digital level. No. So mainly operating on digital level, but at the same time, there are places still we use analog signals. So therefore, when we say digital electronic devices, don't think that it's 100% discrete signals. Mostly discrete signals, but there are situations where still we have to use continuous signals. So that you will understand in great depth when you are doing networking subject. So that is your biggest subject in your AL-ICT syllabus. Right. So there's a reason for that. Then you will ask, why can't we just work only with discrete signals? Why do we want to mix discrete signals and analog signals both? So there's a big reason for that. So those who have done little bit of electronics, can someone tell me? Anyone? This is any advanced. It's, of course, this is not advanced question for someone who has done electronic. But of course, if you haven't done electronic in your O level, it can be a little bit tricky question. But anyone? I just want to check whether anyone who has either interest in electronic or had some exposure to electronic. Anyone? No one? Why can't we 100% use discrete signals in digital electronic? Why are we still relying on some sort of analog signals also? For example, in the computer, internally, mostly it uses discrete signals internally between your microprocessor and memory and so on. Yes, it's this kind of signals, but especially when you communicate with outside devices like networking, unfortunately, it's very difficult or practically impossible to send this kind of a digital signal long distance right now. But things are getting better, especially with the fiber optics and so on. But still, it's quite a challenging to send digital signal in for long distance. But between your RAM to processor, maybe just few centimeters, so we can work with digital signals. Of course, your computer microprocessor is processing digital signals, not analog signals. Okay. Right. Now, when it comes to digital electronics, now we are just narrowing it down. First, we narrow it down to electrical versus electronic. So then we narrow it down to analog electronic versus digital electronic. So then I told you that computer is a digital electronic device. But we further narrow it down and we say that computer is a binary digital electronic device. So if someone asks, how can you explain the computer? The best explanation is computer is, of course, someone can loosely say computer is electronic device. But it is more specific if that person says computer is digital electronic device. But the perfect answer is computer is a binary digital electronic device. So why do we say that it's a binary digital electronic device? Remember, in digital electronics, what we have is discrete states, like this. Only thing is, all of a sudden it changed the state. not continuously like analog. But there can be multiple states. But if you have only two states, so digital electronics can have multiple states, but all of a sudden it has to change. But if you restrict it to only two states, then we call it binary digital electronic. So you can see either this state or that state. But here you can see different levels are there. So therefore, this is digital, but not binary digital. This signal is not a binary digital signal. It's a digital signal. But definitely this signal is a binary signal. So it has only two states, either this state or that state. Okay. So maybe if you call this 1, we can call this 0. Say 1 0 0 1 0 1 1 0 and so. But this may be something like say 2. If you take this as 1, maybe 1 2 3 1 2 3 4 5 6 and so on. So many states are there. But if you have only two states, it must be either one of those states. It's a binary digital signal, or then that device is a binary digital electronic device. Okay. Right. Any questions? Difference between what? Because I explained you so many differences. Difference between analog versus digital, electrical versus electronic, analog versus digital. Then digital I divided into two, binary digital versus non-binary digital. Is it the binary digital versus non-binary digital?
Yes, sir. Binary digital versus non-binary.
Yeah. So the binary digital means, now remember, digital means it has the state change all of a sudden, not continuously like this, all of a sudden. But there can be situations where you have multiple electrical energy levels. Right? Maybe this is one level, another level, another level, another level. Right? Again, it goes like this. So then it is not binary digital, it's digital, because it all of a sudden change the energy level, but it is not binary digital. Binary digital means you have only two states, something like this. So this is say 0 state, 1, say 0 0, say this is time unit, 1 1 0 0 0 1 1 0. So this is a binary digital signal. Right? Binary digital signal. But if it is something like, say this is goes like this. Say this is 0, this is 1, this is 2, again this is 1, this is maybe 3, again 0, this is 1. So now you can see different levels, right? This level, this level, this level, this level. And this is not a binary digital signal. It's a digital signal, but not a binary digital signal. Maybe it is base 4, right? But if it is something like this, it's definitely not a digital signal, it's analog signal. So computer doesn't use this kind of a digital signal. Computer use this kind of a digital signal. Maybe 1 0 0 1 0 1 1 0 and so on. I hope you got it. If do you need more explanation?
No, sir. I got it.
Okay.
Thank you.
Yeah. So that is the difference between binary digital and non-binary. If it is more than two state, it's still digital but not binary. Right. So the computer is, or the modern computers are binary digital electronic devices. Right. Modern computers are binary digital electronic devices. So that is something you must remember forever. Of course, in the future, the computer might become a different device because we are keep changing the things, we are keep improving the things. But right now, the modern computers are binary digital electronic devices. Okay, so it's something like the full name, right? So maybe you can call yourself something like I'm Nimal, but maybe the full name is Ratnayaka Mudyan Selage Nimal, right? Blah, blah, blah. So likewise, okay, we just call it computer. But the full name is, it's a binary digital electronic computer. Okay, binary digital electronic computer. When we just say computer, what we mean is a binary digital electronic device. Okay. Right. So now let's see how does computer represents data and information. Of course, that is our topic 3, right? Representing data in the computer, but at very high level. Remember, I told you computer can process different type of data. Of course, computer can process numbers, text, right? Computer can something like add 35 and 21. It can process characters, right? So you can see this font is bigger, this font is smaller, maybe one font is in red color, another font is in green, another font is bold. So that is, we can process and represent text and characters. We can represent and process Boolean results, true, false values. We can process and store images. For example, this is an image. This is an image. Okay. Graphics, images. Of course, we can process audio and video. For us as a human, these are different concepts. For us, a letter is different from number. A sound, audio is different from image. So those are different concepts. But we have the organs like eye, ear, and for the brain to differentiate those things. But when it comes to computer, how do we remember it? Actually, we don't know exactly how we remember it. How do we process it? Actually, we don't know. For example, I can hear a song and say this is from this particular singer. So that's after processing, I can identify. So how do we do that? How do we remember a song? How do we remember an image? Because when I show a particular photo, you will say, okay, this is my friend Nimal. This is my mother. So you can remember, recognize. How do you do that? So that needs processing. So it's sort of a mystery. And we know that it is done in our brain. And how do you remember it? It's sort of a mystery. But in computer, whether it's a number or text or Boolean result or image or audio or video, it's set of ones and zeros. If it is a binary digital electronic device. For example, you can hear my voice. So basically what you are getting is from my computer to your computer or smartphone through the internet, set of ones and zeros. So when I type a text, what you get is set of ones and zeros. This image is set of ones and zeros. It comes to your computer as set of ones and zeros, and again it is interpreted back as an image by your monitor. So therefore, for computer, everything is set of ones and zeros. Okay, set of ones and zeros. Or binary number. For computer, numbers are also numbers, characters are also numbers, images are numbers, audio is number, video is also number. So that you have to gradually understand why, how. So that is learning ICT. Anyway, we'll look at more details, why it is represented as a number, why is it binary number. So we have the topic representing data in the computer, right? But just for your curiosity, if you are curious, basically the idea is, of course, numbers are quantities. Quantities කියන්නේ අපිට quantify කරන්න පුළුවන් 5යි 2යි 3යි කියලා, right? මං ගාව ටොපි දෙකක් තියෙනවා. වාහනේ ටයර් 4ක් තියෙනවා. But for us, A is not a quantity. Image is not a quantity. A sound is not a quantity. Audio, video. But for computer, number one is, these are more qualitative. But number one is we make them all quantities. For computer, everything is a quantity. There's nothing called quality. Qualities are also quantities. Even the color is a quantity. Red, green, blue value. So this color, you can give it as a number. Red value, green value, blue value. Okay. And then that quantity is not based in quantity. Then they convert it to a binary quantity. So that is how everything become by ones and zeros. So your numbers are converted to binary numbers. Your characters, each and every character is given number. A is this number, B is that number. Of course, Boolean logic can be easily quantified. Maybe true is 1, false is 0. Even image, with the help of colors and so on, we can convert it to a number. How to do that, we'll look at in our topic 3. But here what you have to understand is, for computer, everything is a quantity. Even quality is for us. For computer, it is a quantity. And that quantity is not in base 10 as we humans use it. It is in base 2. Okay. So now the interesting question you must having. Right. So what is the question that must come to your mind? In computer, we quantify everything. As humans, we are comfortable with base 10. Base 10, right? 5,285. This is base 10. But in computer, we don't use base 10, rather we use base 2. So that is how we ended up with set of ones and zeros. So that quantity, we convert it to binary quantity. We don't keep data as base 10 or denary. Another name for base 10 is denary. Denary or decimal. But for computer, these quantities, first they convert it to quantities. We'll look at how it is done later in topic 3. But those quantities are, base 10 quantities are converted back to binary quantities. So that now you must be having question, if you are a smart person, if you are a logical thinker, if you are a critical thinker, what is that question? Anyone? Anyone? Or else I will ask that question from you if you don't have that question. So there are 2 reasons why a person doesn't have a question. One thing is he or she already know the answer. Second thing is he or she is not critical thinker. Therefore, that person is just keep listening, not thinking. So therefore, if you don't have the question, I will ask the question. Anyone? So we keep data in base 10, but computer keep data in base 2. Now what should be the question? Your question must be, if you are a critical thinker, why? Right? Why does computer keep everything in binary when we as humans really comfortable with base 10, and humans have designed this device, computer engineers, computer scientists, electronic engineers. So why these people have designed in such a way that those quantities are kept in base 2 rather than base 10? Because base 10 is something we are comfortable. So why can't they make it more comfortable to us? So that is a question that you must have answer. Right? That is a question that you must have answer as an ICT student. With your O-level ICT knowledge, if you have done O-level ICT, or if you have done this topic already in school or any other place, can someone give me the answer? Why does the computer use binary numbers, not base 10 numbers? Okay.
Because it is its computer language.
No, that is not a reasoning. So that is, we have built like that, and then you say that because it is built like that, right? So that is not a critical thinking question. It's just you accept as a faith, and there's a way they have built it, and you are saying that because they have built it that way, it use base 2? No. My question is, why did they build it like using base 2 rather than base 10? So natural decision should have been what? Use base 10, because we like to build things that we are comfortable. But the computer engineers have decided to keep data in base 2, which we are not comfortable. So that means it's a risky decision, right? So there must be good reason. It understand base 2. What do you mean by it understand base 2? That answer has some sort of a meaning, but still the answer is not very clear. Right. So there are few reasons. We can't explain it using one reason. There are few reasons why modern computers are using base 2 to represent their data. Okay. So one reason is, the main reason actually is, you have to think about how does, now remember this is data related to say 10 and 5, data related to hello, and so on. Then we have to process it. We have to process this data to get our result or information. Maybe that is summation of 10 and 5. Maybe we want to make that text color red and bold. Maybe we want to get rid of the unnecessary background sound from the audio. That is what Zoom is doing. Or you want to beautify your image when you take it from the your cam. So that is processing. So this processing will give you another set of ones and zeros. Of course, as if you use it binary number. Now, to answer why we use binary, first of all, you must know how do we process it. At low level, how do we process data into information? Anyone? How do we process data into information? I think one of you have not muted your microphone. Right? We can hear the background noises. Language translator. No, not the language translator. Hardware level. Which device in the computer process?
CPU.
CPU, correct. Now you have to go into more microscopic level, right? Inside CPU, which device does the processing? How do you call that small part? So CPU means your microprocessor.
Application software.
No. Now we are into the hardware side. Inside CPU, what do we have? Which doing those processing? For example, in our brain, we do the processing, right? So in our brain, which tiny component does the processing? Let's first discuss about our brain. How do you call that? Inside our brain, what does the processing? Okay, now my question is a different question. Forget about the computer. Let's try to understand how do we process data as humans or animals. So we all accept that in our brain, we process data. Just like computer, it is a microprocessor or CPU. What is the tiny or small part that does the processing in our brain? How do you call it? So this is something you must have learned in your O-level science. Otherwise, yes, neurons. Right, neurons. Now, likewise, compatible with neurons. So something like neurons, what do we have in our microprocessor? That is my question. Control unit is not doing the processing. Control unit is doing the overall control. So we'll get back to control unit later. So now my question is, like neurons in our brain, there are tiny parts in the microprocessor. How do you call them? So we call them, conceptually we call them logic gates. So that is why your fourth topic is logic, digital logic, logic gates, AND gate, OR gate, NOT gate, XOR gate, and so on. Okay. And gate is a concept. Like for example, gate or logic gate is a concept. We can even show it like this: AND gate, OR gate, NOT gate, and so on. But this is a concept. So these gates are made of what? Can someone tell me these gates are made of what in modern computers or modern microprocessors? Anyone? So these logic gates are made of what? So very famous electronic device, the most famous electronic item in electronic subject. So that means you guys have not even touched electronic. We are living in the era of computing, IT. So your main subject must be electronic, right? It's no longer agriculture and blah, blah, blah. Right? So that is how the developed countries, Japan, South Korea, America, get into that level. Even India is doing now. So they are exploring the moon now. And they are sending, when we get bankrupt, the India was sending us donations, right? So no wonder. So they are in that mindset. How do you call it? What is the most widely used electronic, tiny electronic device? Like right? Transistor. So there are billions of transistors in your microprocessor, billions. And those transistors make logic gates. So logic gates are made up of transistors. So those logic gates are called Boolean logic gates. Boolean logic gate. Now my original question is what? Why do computers use binary numbers, not base 10? I can still remember the question. Okay, don't worry. So the main reason is we process this data by sending through digital circuits or logic gates. Those logic gates are binary logic gates, so Boolean logic gates, two-state logic gates. So we call that two-state logic, Boolean logic. So there are different type of logic. The logic that we used in computer is called Boolean logic or two-state logic. True, false is there. Every input must be either true or false, output must be true or false. And you can see that it's a two-state concept. Boolean logic is two-state concept. And when two-state processing is done, ideally your data must be in two-state because then it's 100% compatible, right? Your data is in 1-0s. Your logic gates are expecting true, false, or 1-0s again. So when your logic is base 2 or two-state, your data must be in two states as well. So when it is in binary, it is in two states. If it is in base 10, there are 10 states, 0 to 9. So Boolean logic cannot handle 10 state numbers, 10 state things. Boolean logic is two state, true, false. So therefore it needs your data also in two states. So that is the main reason why modern computers are binary digital computers. Binary. In the future, if we find another way of processing other than Boolean logic, of course, we may be using four-state or whatever. That is something actually the computer engineers, electronic engineers are researching these days. Right? And we'll look at that technology in a very brief manner later on under new technologies. So we call them quantum computers. In quantum computers, it is no longer 2-state, it is 4-state. Okay. So, but don't worry about that because quantum computers are still research area. We don't have the practical quantum computers for our day-to-day life. Only big companies like Google has quantum computers and still they are not using it. They are still researching on how to make it reliable. So therefore, now you must have a very good answer. Why does computers are digital, binary digital? Or why does the computer represent data in binary digits, not base 10? The reason is we process using Boolean logic. Boolean logic is 2-state, true, false. So your data must be in 2-state as well. That is the main reason. Right. So now you must have a very good understanding about why the computer is the way it is now. Okay. And there are some other advantages also. When you have only 2 states, it's easier to represent than having 4-state, 5-state, 9-state, 10-state, and so on. Remember, we have to store these data. We have to transmit these data. When you're transmitting 2-state data, when you store 2-state data, it's much more easier to store it, transmit it without any errors. Because managing 2 states is always simpler than managing 10-state or whatever. That is an additional advantage we get. But the main reason is currently the processing devices that we have developed to process data is Boolean logic gates. Boolean logic gates are 2-state devices. Okay. Actually, when we discuss the evolution of computer, you will learn that computing the computer engineers of 1940s, 50s, they tried base 10, but they quickly found that no, it's not going to work. At least with our current knowledge. So that is why we quickly settle into binary digital electronic devices, starting from latter part of 1940s. And so far it has been binary digital computers. Okay. So these initial topics are super important for your confidence. So this will determine whether you do it in a proper way or you just keep memorizing පාඩම් කටපාඩම් මෙලෝ මගුලක් තේරෙන්නේ නැහැ හැබැයි කටපාඩම් කරගෙන you will find that your life is really miserable. Life is stressful because you keep memorizing things you don't understand. But smart people, the life is not a miserable thing. Life is enjoyable things because the more you understand, more you are happy. The lesser to remember, lesser to memorize because naturally it will remember because it's a fascinating story. It's a fascinating decisions made by our fellow humans. Okay. Right. So therefore, in computer, all our data is quantified into binary and we store it in binary, we transmit in binary, and we process at binary. Binary means at processing, we don't say 0, 1, we say true, false. Or if you want, still you can say 0, 1. Okay. Right. I already explained you why binary. Right? Because we process it using Boolean logic, then only it is 100% compatible. And the additional advantage is managing 2-state is always simpler than managing multiple states. So therefore, we don't go for this kind of multi-states. Rather, we go for 2-state, 1, 0. Okay. 1, 0 level. So when you process data, basically, the data is set of 1s and 0s. We apply Boolean logic, 2-state logic to 2-state data. to get our results or the information, which is again binary. Then we can convert it back to whatever the format, right? If it is a number, we can convert it to base 10. If it is character, we are taking the characters. If it is image, now we are building the image. And if it is audio, we are now transmitting audio through your headset or speakers or whatever. So don't worry, we will gradually understand this. So we can't understand everything in a single day. But single day, we look at so many things right now, okay? Why computers are binary digital? Okay. So what do you mean by processing? Basically, we are transmitting these set of ones and zeros into more meaningful or expected results through logic gates in the microprocessor. But it doesn't happen like magic, right? So we are not programming the microprocessor. What we do is we program using high-level languages like Python, Java, right? And that language is translated into next level of low-level language like assembly, and assembly language is translated into machine language or binary logical language. And according to that, the control signals are sending these data through AND gates, OR gates, NAND gates, NOR gates in the microprocessor. So it's complicated process, but that is the big picture. So when you put all those things together, your code is gradually converting into lower codes. Your data is converted to binary, right? And when you put everything together, of course, that will take another few weeks. Right? You will have a reasonable or fairly good understanding about what is computer, how the data is represented in the computer, how the data is processed, what is happening inside the computer when you are doing something. So the idea is after a few weeks, the computer must be not a magic box. It must be something, a very logical, right, device for you. Something that you are really comfortable. Right now, still it may be bit of magic inside that. So magic means you don't know what is happening, right? But let's try to understand more and more and make it more and more clear gradually. For that, you need to put up a lot of effort from your side. I can help you guys to understand it faster. So I try to give it the simplest possible way, shortest possible way, the clearest way, so that you gradually understand it. And the more you understand, you will be happy. So those who don't understand, the A level becomes, right, stress, headache, burden. So those who understand, so you are more confident, you are more happy. Okay, that is how the right way to study. Okay? Right way to study. So just do it in the right way, not the wrong way, because you will end up in a stress. Okay. Right. I already mentioned you that what is mean by processing your data at binary level, because all your data is set of ones and zeros. So those data goes to logic gates, AND gates, NOT gates, OR gates, and so on. So those are having some well-defined circuits. Each circuit is doing specific tasks, and you get different output signals, and that collections of output signal give you the result or the information. And this is happening inside the microprocessor. Right. So right now, the two popular brands are Intel, AMD, and of course the Motorola, and so on. So these microprocessors have billions of transistors. The transistors are used to make logic gates like this. So that we'll discuss gradually. what is a transistor, what is a logic gate. Don't worry, we have to get into those topics. So this is just the beginning. And we can perfectly understand because this is formal science. I told you in ICT subject, you are not going to understand anything halfway, 90%. You are going to understand fully. If not, you have not done your job properly. I have not done my job also properly. Okay. So this is not physics, this is not chemistry, this is not biology. We try to understand the nature. No, this is not we try to understand the nature. This is something man has made, computer. So therefore, we can perfectly understand this. Okay. So when it comes to computer, now we are getting a little bit into the computer architecture. So remember, I told you that the modern computers are general purpose computers. So there's nothing called computer for word processing, computer for arithmetic processing, computer for image processing, computer for audio processing. No, you just have one computer. In that computer, you do all those things, which is superb idea. Right? Otherwise, right, we may be having an audio computer, video computer, image processor, text processor, and the calculator. Luckily, we don't have to carry different processors. Rather, we just need to have our smartphone or laptop or tablet. So who proposed this fascinating idea? Alan Turing. Someone has to propose that, because before Alan Turing, this is 1950s or 40s, we were developing, or computer engineers were developing computers for specific tasks. X computer for X doing X tasks, Y computer for Y tasks, Z computer for Z tasks, and so on. To handle some statistical data processing, one particular computer. To do some other business processing, Y computer. So then Alan Turing, who was a British mathematician and computer scientist, he proposed, why don't we build a computer which is capable of processing anything that is computable in one computer, in one processor. So this concept came from Alan Turing. So therefore, Alan Turing is a very famous person in the history of computing. Okay. Of course, we will look at some other people like A. Ducking, right? Pascal, and so on. But these are more modern computer scientists who propose the concept of general purpose computer. He never built a computer like that. He just came up with this idea. So then another scientist, computer engineer von Neumann, came up with this architecture to make that possible, make that general purpose computer possible. So this is the idea came from Alan Turing. The solution or the architecture came from von Neumann. Again, von Neumann never made a computer. Von Neumann proposed the architecture. So then other people start building general purpose computers based on von Neumann's architecture. We now call it von Neumann architecture. Even the modern computers, we call the modern computers are von Neumann computers. So the modern computers are based on von Neumann architecture. Okay. So this von Neumann also 1940s. So pretty soon he came up with this concept. So therefore, these two guys are really important characters in the history of evolution of the computers. Alan Turing, who came up with the idea of general purpose computer. Von Neumann, who proposed the stored program architecture. So this is von Neumann architecture. So I told you that layered architecture is the computer system, hardware, firmware, software, liveware. Now we just look at the hardware part. So if you take that layer, we just look at the hardware layer, the lowest layer, and we put it into a different diagram now. Of course, on top of that, we have the firmware, system software, application software, and the liveware. So now we look at this hardware. So this is how the hardware components are relate to each other according to von Neumann architecture. Okay. Still, I didn't explain you what is von Neumann architecture is. So in order to explain that, we can use this diagram. Okay, use this diagram. So we can clearly identify different type of devices or components. Input devices, okay, output devices, storage devices, which includes RAM, secondary storage, and if you want, you can have even tertiary storage. Here also we have storage device registries. And this is also a storage device, ROM. Then we have the processing. Inside processor also we have storage part, registries. So we can subdivide the processor into ALU, arithmetic and logic unit, and control unit. Control unit. Okay. So your next task is, as much as possible, clearly understand what is this architecture or arrangement and how it is arranged like that, and what are these components are, or what are the purposes of these components. That is your next task. Remember, we gradually getting into the understanding what is computer. So the more you understand, more you are confident to go for the exams. You will go to the ICT exam paper smiling. So the clever students, smart students, they don't fear of exams. So those who just keep memorizing without understanding, so they cry when the exams are nearing. They cry. Sometimes they get blank, 100% blank. Because the stress is so high. Because they, without understanding, they just try to memorize this and that and other thing. Okay. Right. So let's take one by one. Okay. Now remember, this is advanced level. In advanced level, I expect advanced answers, advanced thinking, serious thinking. Okay. So therefore, whatever comes to your mind initially is your ordinary level answer. Ordinary level answer, because you just finished your O level. Right? You just finished your O level. So therefore, think twice before giving me the answer. Think again whether is it complete answer? Have I missed something? Okay. But it doesn't mean that you always have to give me the perfect answer. Okay, that is fine. But think twice before give answer. Just see whether that answer is complete, whether that answer is, can I improve that answer? So your idea, your task is give the best answer in the world at this level. Of course, I am not expecting a PhD level answers. Right. What is an input device? Anyone? Now don't get scared when I said perfect answer, right? Okay, just give your answer, but just think twice.
The devices that are used to feed data into the computer.
Right. So that is half answer. That is okay for O-level ICT student. Is it only feed data? Or do we use input devices for something else also? If you just feed data, how does your computer knows that it has to process it? You just feed it, right? So what is the second purpose of input devices? For example, when I click on this, is it feeding data? When I select this, is it feeding data?
So is it inputting commands?
Yes, inputting commands. For example, at any time I can say stop sharing. It's not feeding data, it is giving a command. So therefore, what is the perfect answer? Input devices are used to input data and give commands. Give commands. Basically, your mouse is mainly are using to give commands and also pointing things and so on. Keyboard mainly for, yes, input data, but even you can use Control S. Control S means save. Control N, new. If you are in Word or something, I'm giving a command. Save it. That is not input data. Open it. So input devices are used to input data and give commands to the computer. Right? Maybe you enter your username and password, that is input data, then you click on the login button. That is giving a command. Okay. So that is what input devices are doing. Input data and commands. So let's move on to output devices. That is easy. So what is the purpose of output devices? Like your screen, printer. That is output the results or information. Right? Input data, output information or results. Right? Now you know what is the input device or what are input devices or why we have input devices, why do we have output devices. So now let's move on to secondary storage. So secondary storage means your permanent storage connected to the computer, like your hard disk or SSD. Now again think twice, because otherwise you will give me the 50% answer. Why do we need secondary storage? Why? Not feature of secondary storage. Why do we need, or what is the reason? What is the purpose of secondary storage? Like your hard disk SSD. Again, don't worry. Maybe your answer is 50%, but at least that 50% I will accept because something is better than nothing. But try to make it think little bit more. What is the purpose of your hard disk SSD? So it permanently store, right? It permanently store. Yeah, permanently store what?
Information?
Is it information? Is it data?
Data.
Okay. Is it data and information only? So both are correct. So initially we may save data, maybe after processing information. Is it only data and information we store? Or something else is also there? If you take your C drive, which folder take the maximum amount of gigabytes? Anyone? For example, my Windows folder will take few gigabytes, at least 5 gigabytes. Okay, see, no, not 5, even about more than 10 gigabytes. Right? Still it's counting about, right? Now it's closer to 20, right? More than 20. So is it data? Your Windows folder, I think it's closer to 30 gigabytes, still counting. So then what about the program files? Is it data? Right? Is it data? Another about at least 10 to 20 gigabytes. So you said, so this is my hard disk. This is my SSD. Right? So is it data? Is it information? Of course, if I go to my video folder, all the recordings are saved there. That is my data or information. For example, right now, this one is also getting recorded. Okay, still it is not available. right? After some times, it will be converted to MP4. That is data that I accept, or information after perceive. Okay. So files is not a correct answer because data is also files, right? Information is also file. How do you call the other things? Your Windows, Photoshop, Microsoft Office. How do you call them? So those are programs.
Folder program.
Programs. So therefore, we use secondary storage to store, right, data and programs. Your operating system itself is a program, system software. Operating system is a program. Your Photoshop, your Python compilers, Office packages, your browser software. So those are all what programs. So what is the purpose of secondary storage? Secondary storage is used to permanently store data and program. Permanently store means even when you switch off, the power is not given, still those data and programs are saved in the secondary storage, your SSD or hard disk. So you can see every time you give an answer, I find fault with your answer. So that is fine. But after sometimes you must get into a level where no one can find faults with your answer. So your answer is 100%. Your answer is 100%. So then you go to the society also, no one can find faults with you. So you can go to the interview and everyone says, yes, your answer is correct. So we want you. We want you in our organization, not somewhere else. That is the difference between those who are getting jobs and not getting jobs. So some people they go to the interviews and give half answers. Some people go to the interviews and give very nice, clear, simple answers. So you have to get into that level gradually. So that is part of your A level. So you become an advanced, serious person. Right. So now we have discussed input devices, output devices, secondary storage. So let's move on to RAM. RAM. Now think about it again. What is the purpose of RAM? For example, in my computer, there are 8 GB of RAM. I can go to the task manager and go to my performance. So this is my memory. So I have 8 GB of memory. Right now, 7 GB is used. About 700 megabyte is free. So almost entire 8 GB is used right now. Okay. That is the current situation. Now, sometimes it goes down, it goes up. For example, if I close maybe this Word document, it will release a bit of memory. Now it will be, maybe you can see it goes down. But if I start another software, it will goes up. Now, can you tell me, right? Can you tell me what is the purpose of memory or RAM? Memory or RAM? Anyone?
It is used to store data temporarily.
Data temporarily. Is it only data?
Data and programs temporary.
Yeah, now we can see that most of the time when you use the word data, you have to add the programs. Actually, in my 8 GB of RAM, I am pretty sure about 7 GB is right now using. Out of those 7 GB, I'm pretty sure more than 6 GB is program. Maybe less than 1 GB is data. Less than 1 GB is data. So therefore, how can you forget about that programs? Okay. So is it entire program? No. Remember, I showed you that the Windows folder was more than 30 GB. But when my computer start up, it will take about at least 3 GB or 4 GB for operating system. So that is operating system is loaded to the memory. It is not operating system, part of the operating system, essential things. So when I open something like Photoshop, not entire Photoshop is loaded. Some essential program segments are loaded. Okay. Some essential program segments are loaded to the memory. So when I close Photoshop, again that memory is released. Again, more free memory is there. And of course, now, for example, I am using PowerPoint. So PowerPoint software, not entire PowerPoint software, part of the PowerPoint software is now in the memory. And not only that, this presentation is also in the memory. That is why the moment I say next slide, it goes to the next slide. So that is data. That is data. So therefore, what is the sort of a really nice definition of RAM or purpose of RAM? So RAM keeps currently running program segments and the related data. So there can be so many data in my computer, but right now there are so many presentations, PowerPoint presentation. Right now only this presentation is loaded to memory. And part of the PowerPoint is loaded. Part of Zoom software is loaded. This particular software is part of that is loaded. Okay. So that is why we have RAM for your main memory. Okay. So what are the names we use? Main memory, primary memory, RAM. What does the RAM stand for? RAM stand for?
Random access memory.
Why do we call it random access memory? Remember, the most beautiful word is why. So when someone says it's called random access memory, you have to ask why. Why do we call it random access memory? Why do we call it main memory? Because this is the main memory, right? This is the primary memory, which is close to the processor. So why do we call it random access memory? Random. Anyone? No, not currently say. What is the meaning of random? Random. Anyone? Random. What is your random number? සිංහලෙන් නම් ඕලර් කරේ අපි කියන්නේ අහඹු සංඛ්‍යාවක් කියලා. Random අහඹු. Any without any specific logic or preference, right? So random means any. No preference or no predefined logic. So then why do we call the random access memory? Access means access it. Memory means memory. So then why do we call it random access memory? So in IT, this RAM can, in the RAM, there are memory locations that we will look at later. Right? Memory locations have memory address, and each address can keep data or information, data or program or whatever the content. Why do we call it random access? Is, for example, I have 8 GB, so which may be having thousands of memory locations, right? Thousands of memory locations with memory addresses, which we'll discuss under operating system subject, memory management. So any memory location, the access time to access any memory location is the same. There's nothing called this memory address can be memory location can be accessed faster, this memory location or those will bottom access slower. No, there's nothing like that. So in memory, any memory location can be accessed at the same time. So rather than saying same time, so people have, the computer engineers have used the word random time. Random time. So that is why we call it random access memory. Any memory location can be accessed sort of the same time. There's nothing called these are faster, these can be accessed, it take more time and so on. That is why we call it random access memory, okay? But mostly what we use is primary memory, main memory, and so on. Okay. Now, if you want, you can think of the third component also. That is what? This is secondary. This is primary, secondary. What is the third? how do you call the next word? Primary, secondary, English. Prathamika, Dvitika, English. Primary, secondary, what? How do you call the next one?
Tertiary.
Tertiary. So if you want, you can have the tertiary storage. Tertiary storage. So tertiary storage is offline, no backup storage. Actually, I forget to add that. I will add that also to this diagram and upload it later. Okay. Tertiary storage. So tertiary storage is maybe your CD drive, maybe your pen drive. You just keep it for backup, or you just want to transmit somewhere else without the use of network. Or you just backup it so that later, if you want, you can just get it back. So that is called tertiary storage. So tertiary storage is also permanent storage, but we don't keep it connected usually. When we need, we just connect it using USBs and so on. So there again, you can keep permanently back up your data and programs. Data and programs. You can back up your operating system or any other software or your data, your Word documents and so on. Okay. So just take the other one as tertiary storage. Okay. I will add that also to this diagram and upload maybe tomorrow. Okay. Right. So now we have covered input devices, output devices, secondary storage, tertiary storage. Okay. And then we have the ROM, read-only memory. Right. Read-only memory. So remember, in the layered architecture, we discuss about hardware, then firmware. I told you firmware is pretty much like software, but they are so related to the hardware. They are basically running your hardware. So therefore, we just call it firmware. And those firmware is mainly in ROM. Of course, this firmware can be in some other places also, but your main firmware or the system firmware is in the ROM. Right, ROM, which can be loaded to RAM and taken to the processing and so on. So that is another thing, right? ROM. So it keep your firmware. Right, now we are into our final part, or the most important component. Processor, microprocessor, processor, CPU, right? All generation call it CPU. Because all generation like big names, long names, central processing unit. But the new generation, so they like short and sweet words. So we just call it processor or microprocessor. So your microprocessor or the processor is used to process data, right? Just like our brain. Okay. Now, when it comes to microprocessor, we can identify two main components. Actually, the microprocessor can do two main tasks also, right? So one task is processing. Other task is controlling. So controlling is not processing. Controlling. For example, when you walk, you need control. Otherwise, you will fall. So there are some paralyzed people, paralyzed with strokes, high blood pressure, and so on. So they lose their medical issue is with their brain. The blood clots in the brain. So because of that, the control is not good, or sometimes they completely lose the control. So you can see that our brain also doing not only processing, our brain is controlling all the other organs, right? So same thing, the computer microprocessor does processing and the controlling. So that is why we have control unit to do the controlling, control your processor and all other components, and also of course does the processing. So processing is done by arithmetic and logic unit. Actually, registries are part of the ALU. Right? Part of the ALU. But registries are again like RAM, storage. Storage inside the ALU. So why do we call it arithmetic and logic unit? Because it can do arithmetic processing it can use logic or Boolean logic processing. Right? Arithmetic processing, logic processing. So then someone will ask, if it can do arithmetic processing, how does arithmetic keys process? Because about 15 minutes ago, I told you, computer process everything, your data, by using what? By using Boolean logic, right? Boolean logic, logic gates. So then someone will ask, if it is everything is processed using logic gates, so Boolean logic, why do we call it arithmetic and logic unit? Rather, it should have been logic unit. Because I told you that your data is processed by logic. So then how comes this arithmetic gate? Of course, traditionally we call it ALU. But actually, if you want, you can just call it logic processing unit. Because you will later find that even arithmetic processing is logic processing. So any arithmetic processing like adding two numbers, those are arithmetic, right? Arithmetic means add, subtract, multiply, divide. So those things can be done again using logic gates. So therefore, you don't need any other device in the processor. Processor need only logic gates because arithmetic at binary level can be done using logic gates or using Boolean logic. Actually, we look at what is adder, half adder, full adder when we are doing the logic circuit. It's in your AL-ICT syllabus. So therefore, you will find that though we call it arithmetic and logic unit, even arithmetic is at the end logic. So therefore, in ALU, what you need is logic gates. There's nothing called arithmetic gates or whatever. Okay. And then, of course, so the ALU is doing your processing. Control unit is doing the overall control. And then someone will ask, your ALU has registries. What is the purpose of registries? So then only our discussion is complete. Okay. So what is the purpose? So what are the purposes of registries? So remember, ultimately there are instructions, okay, that we want to process. So these instructions has to come to the ALU and they have to remain there, reside there. Those are kept in registries and related data also. They have to kept there until it is getting processed and the results are written back to the RAM. Those things are temporarily kept at registries. So therefore, registries are not, now remember RAM is about gigabytes. For example, my computer 8 GB, maybe your computer 16 GB. But these are terabytes, right? Terabytes, TBs now. But these are registries are just few bytes because just one instruction and related data. If it is a single processor, single core, if it is a multi-core, maybe just, of course, we will discuss what is multi-core, single core later, right? If it is a multi-core, say octa-core, core 8 cores, 8 instructions must be kept and the related data. So therefore, this is just few bytes or few kilobytes of data, right? Data and instructions. So it's very small, but very fast storage inside the ALU. Right. Now we are done with that discussion. So now you must be really comfortable with what Newman architecture, what does input devices doing, output devices doing, RAM is doing, secondary storage is doing, tertiary storage is doing, ROM is doing, the microprocessor is doing overall, and individually what does control unit doing, what does ALU is doing, why there are registries. Okay. So any questions? Because we discussed so many things today. So many things. Any questions? Anything that you want to clarify? So remember, you can clarify it from me or you can go to Google. You can ask from Google Bard, ChatGPT. So don't worry, right? You guys are very lucky. You guys have so many resources. When we did our A-levels, right? When I did my A-level, there's nothing called internet. There's nothing called internet. So we got the internet connectivity when we were in the university. So we had to rely on the teachers and the library books. Sometimes books are not there. We have to reserve and get the book. So when the book is available in the library, they send us mail, postcard saying the book is available. That is how we learn. So you guys have the information in your fingertips. So use it. Don't learn things like your fathers, mothers did it. Your father, mother generation did it. So you guys use the new technology. So we used to physically goes to classes. Right? When it raining, right? So we got caught in the rain. So you don't have to, because you guys are in a different generation, right? You have the technology. So just use it. You have the chat GPT, you have the Google Bard, you can just ask and clarify things. Right. So we went through what are input output devices and what are storage devices. So when it goes up, the storage capacity goes down because we don't need big storage, but access speed is getting higher and higher because the processor need fast access. And out of these, the registries and main memory are volatile. When you power off, the content goes. But secondary storage, tertiary storage, and even the read-only memory, ROM, even when you switch off, the content remain. So we call them non-volatile. Okay, non-volatile. Right. So we have already discussed what is registries, main memory, secondary storage, tertiary storage, and so on. Okay. Right. And also the processor has two subcomponents, ALU and control unit. And ALU has registries as well. Okay. Right. So we discussed this one also. So your processor or your CPU has logic circuit components, adders, encoders, decoders. We will look at some of those later. And those are capable of doing logic operations, or we call them logic gates. And those logic gates are made of electronic gates. Modern electronic gates are made of transistors. We will look at that more details when we do the logic, okay, digital logic and digital circuits. Okay. So what is a logic gate? So that is an interesting question you have to clarify today itself. Right? What is mean by electronic gate, or what is mean by logic gate? Logic gate or Boolean logic gate, AND gate, OR gate, right? XOR gate, NOT gate, and so many gates are there. So first of all, so today itself, you have to understand what is a logic gate is. So first of all, let's try to understand what is a gate is. What is mean by gate? What is mean by gate? So every house these days have a gate, right? Almost every house. So gate is a device or some sort of a mechanism. Either we allow the flow of things or we do not allow the flow. If it is normal gate, whether others people can go through it or they cannot go through it. That is what is my gate. So in electronic gate, it is the flow is electricity. If the electricity can go through it, we say that the gate is open or the gate is on or gate is 1. If the electricity cannot go through the gate, at that moment we say the gate is off or the gate is 0. Okay. So that is electronic gate or electrical gate or electronic gate, because it's electricity that goes through, not water or humans or whatever. So then what is mean by logic gate? Logic gates are electronic gates, right? So logic gate means how do you decide whether electricity must flow or not is determined by logic. Right? For example, if it is an AND gate, AND logic gate, When both input have electricity, then only it allows electricity to flow. But when at least one input has no electricity or input is 0, now electricity is not allowed to go. So it uses AND logic to decide whether electricity is allowed to go or not. So similarly, OR gate, when at least one is having the electricity, it allows you to go 1 0 0 1 1 1, it allows you to go. But if it is both 0 only, it doesn't allow you to go. But in AND gate, only 1 1 will allow you to go, but 1 0 0 1 0 0 will not allow electricity to go, and so on. So now you must have a very good understanding about what is logic gate is. A gate is something that allow or not allow. Electronic gates, it is the electricity that can go or not going through that. And logic gate is, or logic electronic gate is, electricity is allowed or not is determined by AND logic, OR logic, XOR logic, NOT logic, and so on. And your microprocessor has billions of these logic gates made of transistors. Right. So that's it about introduction to computer. So I hope you have a really good foundation idea about what is a computer is. So above average understanding. Right. Above average understanding or superb understanding at your level. Right. So computer is a general purpose data processing device. Computer combines hardware, firmware, and software. Computer is a binary digital electronic device. Right? Computer stores data in binary digits. Computer process data using Boolean logic operations. And of course, computer is made of component architecture. And also, it communicates through different communication buses that we have not discussed yet, which we will be discussing later when we are doing computer architecture like data bus, control bus, address bus, and so on. Okay. Right. So now your task is in the Google Classroom, there is a quiz. So make sure you open the quiz, do it by yourself, and see whether you can get 100 out of 100. If not, all right. So you must be able to get 100 out of 100. Right. Make sure that you are looking for the best. Right. Don't settle for anything less than the best, less than 100. And once you submit everything, right? Once you submit everything, okay. So it's not okay. So it's past 6, right? So I told you that I promise you that I won't take more than 2 hours of your wonderful time, right? So therefore, you have to do it by yourself. It has only about 15 questions. Only one answer is correct. Once you submit it, right? Once you submit it, right, there's something called view score. Then you can see which answer is correct, which answer is wrong. Of course, in this case, all are wrong because I never tick any of the questions. Okay, so you can see which one is your correct, which one is wrong, and you can see the marks also, right? So that you have to do it by yourself. Better you do it today itself. Maybe again go through the note and do it itself, right? So I don't track your marks. You can even log out and you just anonymously submit. I don't mind because your results are for you, your future is for you, right? So we don't track. Actually, I'm someone who highly oppose exams. I hate exams. Exams completely block you learning things because the more you think about exams, you forget about learning. You forget about enjoying your studies. But anyway, this is Sri Lanka. We have very competitive examination system. So therefore, this is not exam. This is just to check yourself whether I have understood it well enough. If not, you have to think a little bit more. Again, go through the notes, ask more questions. Right. So WhatsApp group is available for you 24 hours, 365 days. At any time, you can ask questions, and I will be answering each and every question as long as it is in the your WhatsApp group. Okay. Right. So we'll stop at this point. Right. Thank you.